In part 2 here, we want to take a look at second order equations that have no explicit x's. And here are some examples of what we're going to be looking at. No x's. Now all of these are referred to by the name autonomous. We'll talk more about that in class. For right now, it just basically means that you got all your stuff equal to 0. And we're going to change our substitution just a little bit. Instead of just using v, meaning v as a function of x, we're going to use the substitution dy dx, or y prime, equals v as a function of y. Now all that means is to do the second derivative of this, we need to use the chain rule. And so we'll use this substitution, dy dx equals v, meaning v is a function of y, and the second derivative, d2y dx2, or y double prime, equals v times dv dy. Well, let's see how that works. So to do this example, we're going to use the substitution y prime equals v and y double prime equals v times dy dx. So here's our y prime that we're going to be substituting a v for, and here's our y double prime that we're going to be substituting the v times dv dy for. So let's do the substitution and then analyze that for solving it. We'll do a little bit of algebra, and notice it's separable. And so we'll integrate both sides and try recovering the v. So we'll substitute the dy dx back in place of the v. Where we originally substituted, we'll unsubstitute and then finish solving from there. So there's our process when we have no explicit x's. And for this last example, we'll solve an initial value problem. Again, since we have a second derivative, we are given two values, the value of the function and the value of the derivative. However, we still are using the substitution. Y prime equals v and y double prime equals v dv dy. So here's the substitution. We do a little algebra to rearrange things. And it's the same thing that we did earlier. Separate, integrate, solve for v. We'll replace the v back with the y prime. Only this time we'll use our initial condition, y prime of 0 equals 2, to figure out that constant before we go any further. Then we'll finish that by solving that differential equation. And again, we would like to recover the y. So we can use our other condition, y0 equals 0, to find the final constant.